United Lutheran Seminary presents the Seminary Explores podcast, conversations on faith, art, people, politics, theology, life, and more, with voices from around the corner and around the globe.
Getting up close to Climate Up Close. Hello, I'm Jerry Christensen, and this is the Seminary Explorers. We're going to talk today to two climate scientists from the group known as Climate Up Close. They are Nather Jivanjee and Nathaniel Tarshish. Now, if I read you their bios, it'll take most of the program, but at least let me say this. Nather studies physics of clouds, radiation, and climate. He holds a PhD in physics from University of California, Berkeley. He is currently a Harry Hess postdoctoral fellow in the Geosciences Department of Princeton University, where he is also affiliated with Princeton's Department of Atmospheric and Oceanic Sciences and the Geophysical Fund Dynamics Laboratory. I told you that it takes up most of the program. But Nathaniel Tarshish is a graduate student studying the physics of climate at UC Berkeley, University of California, Berkeley. Prior to graduate school, he earned his Bachelor of Science in Mathematical Physics from Brown and investigated ocean fluid dynamics as a researcher in Princeton University's Department of Geosciences. Is Princeton a common denominator for many of you? Is that where you kind of met? My question is going to be, how did you meet? How did this get going? What's your mission?
Right. Yeah, so we're a relatively new organization. We got started this past fall. And the motivation, individually, I think the way we got here was really through physics. Mm-hmm. And we studied various things in physics. I was looking at liquid crystals in my undergraduate thesis. And at a certain point, I realized that, the ocean and the atmosphere were also fluids. And that the same laws I had learned in my fluid dynamics class also govern these interesting things that we interact with every day. And so that was the start of a journey into really the physics of climate science, and one that I think is very similar for Nather, if you want to touch on that.
Yeah, I had a very similar trajectory where I was studying quantum gravity, so very theoretical problem of how to combine quantum mechanics with Einstein's theory of general relativity. And like Nathaniel, I was hearing and reading and even doing some teaching relevant to climate science and renewable energy, and realized that these same fundamental fluid physical laws that I had studied were relevant. And thought that, wow, if I could apply, the stuff I know to these problems that are so urgent and that I'm reading about on the front page every day, well, that sounds like a good way to go.
And you wanted to communicate this with the general public, and so you're taking time out now from what could have been a vacation time or further graduate studies or postdoctoral studies, and actually coming out and talking to people. Did you invent the name Climate Up Close for your group?
That's
or are
right.
you part of a larger organization?
Yeah, so right now the group is everybody you saw today, the individuals who gave the talk. And we came up with the name. There was a long list on a Google Doc, and we went through and we voted on which one, and Climate Up Close rose to the top. Okay. And maybe to answer your question about what motivated us to perform this outreach. So there, I think that as we made that transition from physics into climate science, we started becoming aware of a gap. And it's a gap between what we felt like was the national conversation happening in the media and in politics on both sides of the aisle and around the kitchen table, and the conversation that we were having in our scientific labs and in the classroom. And that gap felt like it was something that there needed to be activity on the part of scientists to bridge. And that there was kind of a dysfunctional conversation between scientists and that national conversation that we could play a role in bringing closer together.
And sometimes it seems distant to some of us non-scientifically oriented, or even people who know the field, but the technical terms are often. And you are presenting the issue with a PowerPoint and with demonstrations that are about as straightforward and accessible as at least I've been able to see or hear.
I think that's why it's called Climate Up Close, right? It's like we want to take things that seem a little bit mysterious or inaccessible and make them accessible. And I think that's twofold. It's both bringing the science to people and trying to present it in a way that's accessible. So really distilling down the concepts to their fundamentals and getting it across with analogies and experiments. But the other thing is also face-to-face contact, right? I think often, one thing that we talked about in forming this group is that an issue is certainly not only an understanding of the science, but to what degree do people trust climate scientists? And we had the perception that there was maybe a large swath of the country that maybe they don't know people who have PhDs or are scientists, and it might be easy to think of those scientists, those people at these elite universities. And so we wanted to get out of our bubbles that surround these elite universities and talk to people who might not otherwise come across a PhD or a scientist or a climate scientist, interact face to face.
Interesting dichotomy sometimes. I'm also an academic, as this audience knows, and there's a kind of a dichotomy in general in America these days between academics and people who think that they know reality. In fact, one of the questions that came up in your discussion today is, let's get real, after a whole hour presentation of reality. At any rate, you were going to say, and I interrupted that.
Oh, no, yeah, I was just going to follow up on that there's this physics idol, Richard Feynman, and he has this fun line that you don't understand anything until you can explain it to your grandma.
There you go.
And so this is a two-way street.
Yeah.
And boiling down the science into something that could be really well received by the public is a challenge. And we're hoping that over the course of this organization's lifetime, that distillation process can be refined more and more. So the audience is key.
Let me extend that one more point before we go on to the science and what can we do about it as individual Americans and human beings. But your mission includes extensive travel this summer. We're here in Gettysburg broadcasting today. Is this it, or are you on your way somewhere else?
So for this summer, our one tour is in the southeastern Pennsylvania area.
Mm-hmm. Okay.
And we hope it in the future to have many tours and throughout.
So you're not going to close down after this tour of Southern, even though we're going to give you a good send-off and a warm welcome, and you're going to...
This is the trial run.
I got it.
This is the test run. And
let me at least be one to testify that was very, very well done. You have a power... If other people have an opportunity to contact you, where would they do that?
You can go to climateupclose.org.
Okay.
And there'll be a link to reach out to us, and you can reach us.
We're talking to two persons who are part of, at the moment, a 4-person team called Climate Up Close, and we're talking about not only what their mission is and how they got started, but we also want to talk about actions that we can take, but in the meantime, we need to know a little bit about the background and the science. Our guests are Nathaniel Tarshish and Nader Jivanjee. I'm Jerry Christensen. So what would you take as the number one, well, at least the most illustrative scientific concern for mainly in climate right now that you want us to know about, that you're trying to address? What's the transition to our action, in other words?
Well, maybe we should set the stage a little bit for what the problem is.
Yeah.
And so here we're talking about greenhouse gases. So in the course of industrializing over the past 150 years, we've relied on fossil fuels, oil, gas, coal, to fuel that industrialization. And in doing so, we've put a lot of carbon dioxide into the air, which is making it harder for the Earth to cool. Mm-hmm. So in terms of cooling, our choice now is really how much more warming we want to get. That's in terms of action, that's what we have to decide. So far, we've burned about 500 billion tons of carbon. That's roughly equivalent to all the carbon stored in trees today on the face of the Earth. So the change we've made to the planet is as if you had burned all of the trees from a carbon perspective. And that's given us about 2 degrees Fahrenheit in warming. Now, maybe Nader wants to touch on how do we connect the warming we've got with the carbon that we've burned?
Yeah, so I think one scientific result that maybe hasn't made its way out into the public discourse, but is informing policy, is that the temperature changes that we see are a result not of our annual emissions or the rate of emissions, but actually the result of the cumulative, the total emissions that we've made since industrializing. Mm-hmm. And so that's why this 500 gigaton number, that's adding up all our emissions historically. And it turns out that a scientific result is that the warming we see is just proportional to that. And so if we double that cumulative amount of warming, more or less irrespective of how fast we do it, we're going to get double the warming. So there's a few, I think, important implications of that. One is that if we shut off everything today, stopped all the cars, shut down all the power plants, then we've had about, as Nathaniel said, 1 degree Celsius or 2 degrees Fahrenheit of warming, and that would basically stay steady for actually hundreds of years. And so I think that's an important, potentially clarifying point for the public to hopefully appreciate.
Yeah, I thought it was one of the most dramatic things you said today. Now you're talking to a layperson that there is a proportional relationship here that we weren't aware. You didn't know if it's just going on and can't stop. In fact,
exactly.
It's not a difficult measurement on the surface.
Correct. It's not difficult to understand.
Yeah, that's the way
relationship,
to put it.
And I think that's one of our goals. In this endeavor is to bring some clarity regarding issues like this, because it can be such a fog of, well, I'm emitting, and we emitted this much last year. What's the impact on temperature?
Yeah.
And
what can we do about it anyway? It's out of hand already. So live free and die coughing.
Yeah, I mean, it's easy. It can be easy to despair. So the temperatures, the temperature change we have now is due to all of our cumulative past emissions. We stop everything; the temperature stays where it is for a very long time, hundreds of thousands of years. So that means that any future warming is going to come from future emissions. So if it gets hotter, it's because we emitted something in the future.
Got it.
So in that sense, that's kind of a glass half full perspective, and that future warming is up to us, right? At the same time, the warming that we've already gotten, it's not going to reverse itself naturally for a long time. The Earth will come back into equilibrium, the equilibrium that we had before industrialization, but that will take thousands to tens of thousands, potentially even 100,000 years for that to happen. So any reversibility is going to come from our own actions. Afforestation, reducing deforestation, sucking carbon out of the air.
But another dramatic, the other I think of the two was that there is actually something that could be done, and we could reverse that proportion.
Right. So we can't reverse the warming that we've had.
Let me let you do all the stuff you want as background.
Right.
But you can tell I'm anxious to get on to action. But if you've got more science, tell me about that first.
Yeah, I just want to clarify a point that we can't reverse the warming we've done in the past, but we can determine what warming we get in the future. And as Nather mentioned, the quantity of interest is just how much cumulative carbon is in the air. And we control, over the coming century, how much we put in the air. So you might wonder, is it technologically possible to lower that amount? Do we have proven strategies to do that? So to orient you on that, we're putting about 10 billion tons of carbon a year into the atmosphere. And it turns out that there is a tool belt of strategies and technologies that can help bring that down. Now, which particular option you choose, and maybe I'll list a couple of them, is really not up to us as Climate Up Close, and we don't have a horse in this race. We think that's a policy question, and we're not policy experts. We're not politicians. We're not pushing for any. We're just trying to point out that the scale of the solutions that exist today is commensurate with the scale of the problem. And so some of those solutions include ending deforestation, because converting forest land to agricultural land puts that carbon that was stored in the forest back into the atmosphere. Others include switching to fossil-free fuels, so moving away from fossil fuels and to things potentially like renewables or like nuclear energy, as well as electrifying. So taking cars and moving them away from burning fossil fuel to working off of electric power. And the list goes on and on and on, and it really does. There's this nice paper that I'm kind of speaking from, and it identifies 40 strategies which could all play a meaningful role in reducing our carbon emissions.
If I were to imagine this, I could see 10 tons, let's say, of excess carbon dioxide in the atmosphere. Each of these you've talked about might reduce that 10 tons by a ton or half a ton or something, and we might actually get back to stasis after a number of years.
Yeah, that's right.
Stasis meaning today's emission or yesterday's, or what's the goal? I'm sorry, what's the goal? Back to 1950, back to industrialization?
I mean, so that's an excellent question. So, I mean, one thing that politicians have debated is what's the goal, what's the target? And so a recently agreed upon target was to limit warming since pre-industrial to 2 degrees Celsius, roughly 4 degrees Fahrenheit. We've already gotten half of that already half of that warming has already occurred,
Okay.
right? And so the goal is to try and not warm a further 2 degrees Fahrenheit. And so to do that, so there is some carbon that we can emit, another 500 billion tons.
Which is roughly the amount that we've emitted historically.
Already.
Exactly,
Yep.
exactly.
Yep.
And so then if you note that we're emitting roughly 10 billion tons a year, then that gives you something on the order of 50 years of emissions at roughly the current rates. Now, that's not taking into account methane and other greenhouse gases. It's not taking into account the fact that emissions are increasing with time. So it really is a rough estimate. More realistic estimates would be a bit lower, maybe closer to something like 30 years. But so that sets the scale. So if that's our if that's our target, and it seems that the international consensus has been around that target, then that's sort of the task, is to within roughly a generation to bring our emissions to net zero. And then there's a sort of suite, as we discussed, of options for sort of how to get there. And one thing we didn't touch upon is, are there ways to pull carbon out of the atmosphere? I guess we did touch upon carbon sequestration,
Yes.
which allows you to continue to burn fossil fuels, but the CO2 never makes it to the atmosphere. You capture it, and then you sequester it underground.
That fascinated me. Is it as simple as capping a chimney somewhere or a smokestack, capping it with something that recaptures and sends it back into the factory, or a little bit more kind of complicated than that?
I mean, the actual chemistry of what's going on to extract the CO2 is obviously more involved, but that's the basic idea.
Okay.
You go to the source of the CO2, you capture it, you transport it to a geological storage facility where you can pump it deep underground.
Okay, all right.
You got that part right.
It can't be reused. It's going to be stored forever.
So, it's carbon dioxide. So, I mean, if you have a particular novelty usage for carbon dioxide,
we might invent something that's.
Well, I mean, there are, right? So oil companies actually purchase carbon dioxide to increase the pressure in their reservoirs.
Yeah.
And in fact, I think some of the proposed reservoirs for sequestration are old fossil fuel deposits because they are sealed in the appropriate way, such that you can drill in and not worry about it leaking.
I've been getting you off on a couple of tangents, but you had listed 2 or 3. One would be deforestation as actions, possible actions.
Right. So
one would be carbon dioxide emissions, which we hear about an awful lot. Did you mention some others, and are there still others on our list of, if we're trying to reduce by 10, that's the 2 biggest ones, I imagine.
So, the biggest that's not exactly what I was trying to say. Sorry if it came off that way.
No, that's me.
So we have a bunch of tools, and depending on how extensively you rely on one tool, you could Sorry, let me step back. So we listed a couple options. We had deforestation, turns out changing to no-till agriculture from till agriculture. We have renewables, electric vehicles, and the list goes on to down to 40.
Yep.
You could pick a subset of those and implement them to their fullest extent, and that would get you to zero carbon emissions. But there's many such subsets you could choose, and there's not a clear silver bullet. So it's really up to you to decide which strategies you'd like to take.
Yep. Where do you go from here? What's been the response of the people so far? We touched on some of the reasons why you did this in the first, why you're doing this. We touched on some of the issues that cause concern and got your group together as it does other people. And we've talked on some strategies. But now, where for Climate Up Close, where do we go from here? Another couple of years you're in graduate school, you're in postgraduate work, gather together next year to make more contacts with people around the country?
That's right. I think so far it's felt like a really meaningful and productive outreach, and we hope to just continue going forward. And if we end up learning lessons about how to communicate science to the public, sharing that with our scientific community.
You know, the one thing about contacting today was that it was personalized. It was a PowerPoint presentation. You're on the podcast here. The personal communication has made a lot of difference between reading scientific facts or controversial issues in the newspaper, bringing it up close like you want to do. Nader, what's your hope for the future?
Yeah, I mean, I think the responses have been positive, and people really seem to appreciate our presence and us coming down here and taking the time and trying to deliver the science accessibly, which was our hope. So I think we're encouraged, and we feel like this thing that we thought would be useful is. So I think we're going to continue to do it. Maybe a personal comment along those lines is that I feel that for me personally as a scientist, I'm being paid to do research. It feels like society is saying it's worth spending a little bit of money to support people who are going to study, some of these subjects deeply and learn things about it that the rest of us just don't have time to do. But I think a sort of a flip side of that bargain is that once we go down these scientific rabbit holes and we learn things, I feel the responsibility to come back up out of the rabbit hole and talk to people and tell them what we've found.
Here. Yeah.
So for me personally, that's why it's important to do this work and to continue to do this work. Otherwise, I feel that as scientists, we're not fulfilling our obligation to society.
Amen and hallelujah. Nader Jivanji and Nathaniel Tarshish are our guests today. They're both scientists, and they are both members of Climate Up Close. And we've tried to get up close with Climate Up Close. I'm Jerry Christensen, and for the Seminary Explorers, have a very good day.
You have been listening to The Seminary Explorers, a production of United Lutheran Seminary with campuses in Gettysburg, Pennsylvania and Philadelphia, Pennsylvania. We invite you to visit our website at unitedlutheranseminary.edu. Opinions expressed on this program are not necessarily those of United Lutheran Seminary or the Evangelical Lutheran Church in America.